Hello everyone, this is Mr. Hussein Wasapi, and in today's video we'll be looking at deformation of solids, that is in physics. Anyway, let's first understand what is meant by the term deformation. When we talk about the term solid, I bet everybody understand what it means. So the term deformation is describing, in short, what forces are simply acting on a solid object to the point that its spacing of the atoms within the particular solid are changed or affected to a small extent. Now, the changing in the spacing changes the external structure or shape and size of the solid, and that condition is what we call deformation of solids. So be mindful of what I have actually said. Alright, so in a nutshell, I would say a change in shape due to the application of a force is what is known as deformation of what? Solids. Now, to easily understand this topic, we need first to understand the terms that are used under this topic. So now, what are these terms? Alright, let's start with basic terms. For instance, load. This is not the first time we're hearing the term load. Now, a load is simply just a force, or in short, we could say the weight that is attached to a spring. We have seen a spring before. You could have a horizontal surface like this, and say a spring could, let's be, say, attached to a certain system. Now, this system is what we call the load. So, the force or the load or the weight attached to a spring is what we are calling here in the diagram as a system. So the load is just this same particular weight or force attached to the spring. This is a spring. Alright, it's good that we have understood what a load is. Let's move on to a different term. The second term we'll look at is what we call elastic change. Elastic change is defined to be the ability of a material to go back to its original shape and size when the load or force, to say, that was attached to it is what? Removed. If you visualize a simple elastic band, if you stretch it with a certain force to a certain length and say let go at one end, you'll find that elastic will go back to its original shape and size when the force that in turn stretched it is removed. So now that ability of the elastic band to go back to its original shape and size when the force that was applied to it is removed is what we are calling what? Elastic change. So elastic change is very important in this topic to understand. Alright, let's move on to the third terminology. So the third terminology is what we call extension. Extension is defined to be the increase in the length of a spring or what? A wire. Now the formula for extension, x is equal to length final minus what? Length initial. The unit for extension are simply what? Meters. Others could also use what? Centimeters. It really just depends on the prefix that you want, but in most cases we go for what? The basic, which are what? Meters. I hope it's clear. Alright, to easily understand what extension is, we can maybe look at an example that relates to this. Say a light spring of an extended length of 16.8 centimeters is suspended vertically from a fixed point as shown below. If a mass of 4.8 is hung from the spring, the length changes to what? 20.5 centimeters. Calculate the what? Extension. Now here the extension has not been what? Specified to which units we should supposed to what? Put them. So here in short, we are having 20.5 centimeters. Now the goal is to calculate the what? Extension of the material. Alright, so let us do that. So remember this, that extension x is equal to length final minus length what? Initial. Now, what is your final length? Your final length is the length that you got, or the length that changed. So what was the change that we had? That was what? 20.5 minus the initial length that we had, which was what? 16.8. Now if you do the math right, you find that your extension is what? 3.7 what? Centimeters. As simple as that. This will be what? Our extension. Remember that extension is simply the increase in the what? Length of what? The spring. So this is showing us to say that 3.5 centimeters was how much the length of this spring had increased when the force or the load was attached to the spring. I hope it's clear. Now, what you need to understand is this. I said that in most cases, the extension is put in what? Meters. But if not specified, you can let it be in centimeters as it is. So, future examples will have, different ways of finding this extension, depending with a topic that you will learn in future. But just for the sake of other people, we can convert this. We can say, okay, extension can also be equal to what? Extension can also be equal to, now 3.7 centimeters converted to meters is just 0.037 meters. As simple as that. Alright, let's now move on to a different terminology now that we have understood what extension is. This terminology is what we call the proportionality region. Now, this is simply just a region where the force is directly proportional to the extension. Okay, I hope we understand what it means to be directly what? Proportional. Okay, if the force increases, even the extension what? Increases, because we're saying that the force is directly proportional to the what? Extension of the material. So when the force is directly proportional to the extension of the material, then that is what we call the what? Proportionality region. So be mindful of this terminology. Now the proportionality region is very simple to understand, and here the material is still able to experience what we call what? Elastic change. Elastic change is very simple to understand, and we did make mention that this is just simply the ability of the material to go back to its original shape or size when the force or load that was attached to it is what? Removed. Alright, it's good that we understand what this terminology really is. Let's move on to the next terminology. So the fifth terminology is what we call the proportionality what? Limit. You know what it means when you say it's a limit? Yeah, so this is a point at which the extension of the material is no longer directly proportional to the what? Load or force. However, the material will still experience what? Elastic change. So here the extension is no longer directly proportional to the what? The force, and neither is the force directly proportional to the what? Extension. So the force is not directly proportional to what? The extension, which means that the force, if the force increases, it doesn't really necessarily mean that the extension will also what? Increase. That's what it means when we say proportionality to what? Limit. It's that point where the force will no longer be what? Directly proportional to the what? Extension of that particular wire or spring. I hope it's clear. Let's move on to the sixth one. Now, this is what we call elastic limit. Elastic limit. Now, to easily understand elastic limit, this definition that I've given you is the best definition you can ever come across on elastic limit, because elastic limit is simply just the maximum force or the load that can be applied to a wire or spring such that the material returns to its original length when that particular load or force is removed. Okay, be mindful of that. Elastic limit is just the maximum force, like how much force, how much load can I attach to that to that spring in order for it to experience that elastic change. I hope it's clear. Let's move on to the next terminology. There's what we call a plastic region. So now this plastic region, like we all know what plastics are. If you look at basic plastic, basic polymers that we have, like bottles, you'd find that when you talk about the term plastic, if you stretch a plastic, you cannot expect that particular plastic to go back to the original shape and size, because that plastic is in a region where it is now going to undergo what is called deformation. Deformation is a permanent change in the structure of a material. So when we talk about the plastic region, this is simply just a region beyond the elastic limit, whereby a material becomes permanently deformed. So this process of a material becoming permanently deformed is what we call plasticity. When a material is in the form that we call plastic, it means that upon it being stretched or compressed, upon that force that was applying, either the compression or the tension is removed, that material will not be able to go back to its original shape nor size once that force is removed. Be mindful of what plastic region is. Alright, let's move on to the next term. So we have what we call the breaking point. The breaking point is simply a point where you break. Basically, that's what it is. But anyway, the breaking point is simply just a point at which a spring or a wire breaks. Okay, so that's the breaking point. It's that point whereby you put a certain force out, just make that wire or spring to break. So that's the point at which the spring or wire breaks, literally. Alright, let's move on to the next term, because this one is a bit simple to understand. We have the ninth term, which is compression. Compression is simply just a decrease in the length of a spring. Unlike extension was defined to be yes, the increase, but the decrease in the length is what we are referring to as compression. So compression and extension a bit related. It's just that extension is the increase in length, while compression is a decrease in the length of a spring. Alright, let's move on. Now the 10th term is what we call the spring constant, mostly symbolized as K. Now this is the measure of the stiffness of a spring. Now the larger the spring constant, which is a K value, the stiffer the spring will be, and the more difficult it will be to stretch that material. You have found, or let's just say you have, I don't know, but if you have ever experienced where a condition whereby you're trying to pull a spring to a point, you're trying to, let's say pull, you're trying to extend the spring to a certain length, but it is very difficult for you to extend it. Now that difficulty or stiffness that spring has is what we call the spring constant. So the measure of the stiffness of a spring is the spring constant. And remember, the larger the spring constant, the stiffer the spring, and the more difficult it will be to stretch it. Now the last thing we need to understand are all these terminologies put in a graph, and this graph is what we call the force versus extension graph. In most of your labs that you'll be doing, you will learn about this graph. So the force versus extension graph looks like this. We have what we call the proportionality limit. Remember what the proportionality limit is, isn't it? We looked at it. It is simply just the point at which the extension of a material is no longer directly proportional to what? Yes, the force that was applied to it. So at this point here, this straight line here, the line is straight for the proportionality region. This part here is the proportionality region. Here the force is directly proportional to the extension of what? The material. But be mindful that the gradient on this line will always give you the what? The spring constant, the K, the measure of how stiff that material or spring is. Then the elastic limit is here, and this is the point that we discussed to be simply just a simple thing whereby you are trying to look at the maximum force or load that can be applied to this particular spring, such that this wire or spring will be able to return to its original length when the load is removed. Then the breaking point is just the point at which the material breaks. The wire will break, literally break. Then be mindful that the area under the graph will always represent the energy stored by what? A spring. We'll get to understand all these terminologies when we move further with this topic. But in this lecture, I just wanted us to understand the terminologies that are attached to what? The deformation of solids. The moment we understand these terminologies, the better it will be for us to understand what deformation of solids really talks about. So this concludes the end of this video. My name is Mr. Hussein. Mwasapi. Remember to like and subscribe to this channel. If you have any queries, contact me on that number that is on top of the screen, as you can see, or you can simply just use the number that I'll put in my description. Alright, remember, it is very important to strategize before you become a statistic, and let's try by all means to get that A+.